Guys, can you guys see my screen?
Yeah.
Okay. So, we're first gonna start off with this is from previous. We're first gonna start off with the newer topic that Obrenic went over, which are train machines. I'm sorry for taking a while to write it out. I'm like on my pad right now. And then pumping lemma. So I'm going to be starting off with the fall 2023 previous exam. And let's start off with Turing machine problems first. So I think I skipped a few. So the okay, the exam is going to be filled with like Turing machines, pumping lemma, and as well as uh some older topics such as regexes, context-free grammars, and then automatons. So please do focus on the problems that you're more comfortable with solving. I know for a lot of people that's like regexes and such. Um I think Turing machines is also pretty on the easier side than pumping lemma because it can be a little bit tougher with pumping lemma. But let's start off with problem 26. Then copy it and then paste it. Okay. So these are my instructions, like the set right here. These are my instructions for the Turing machine. And how you read the instructions is that the symbol on the left all the way to the left side is the state that you're currently in. So stay in. And then the second symbol is what you see on the tape. So for over here, it's like an A, right? So this is the letter you see or the um stigma that you see. You could also see tape alphabet, which is like over here, the tape alphabet is basically everything you could see on the sigma plus the additional uppercase letters and blanks. So blanks are basically what the tape is, right? The tape is like filled with it's like blanks infinitely to the uh right side. This is a one-way tape, so it's infinitely to the right side. And you could encounter a lot of blanks. Okay, this is the state you're in. This is what you see on the tape. Letter or number that you see because I know sometimes she can also give you guys binary instead of like ABCs. Letter you see. And then after that, this is the state that you go to. So over here, there's the X go to state. And then this is whether you turn right or left. Am I missing something? Wait, okay. Oh, I'm sorry. So the fourth symbol is what you rewrite the letter that you saw with. So over here, you see a lowercase a, you rewrite that or like you replace it with the uppercase A. Um, I think I should write it a little bit smaller because it's getting replace letter with. And then the state that you go to, I mean the state that, oh, the way that you turn the tape head. So in this case, you're turning it right. So you could either turn it right or you could also turn it left. There we go. Let's get rid of this. So for these, what helps out for most people is doing it. There's two methods to solve this, right? There's one with automatons. You could write out the instructions and then make an automaton out of it. Or you could do the tape method. Now, I personally think, for me, I find the automaton to be a lot more clearer because, like, you could see the state transition, like the from, let's say from Q, you're going to state X, right? So that's what we're gonna do. And then later on, I'm also gonna show the tape method because a lot of people also find that more helpful. So like whatever fits your style, right? So let's do the automatons. We start off with state Q. In state Q, I could see A, B, or C, and then they all take me to state X, right? So from state Q, I could go to state X. And what takes me is A, B, and C. A, B, and C. And then I'm gonna write what they transform into. A lowercase a transforms into uppercase A. A lowercase b transforms into uppercase E. And then lowercase c transforms into uppercase K. And then I'm going to write which way the tape is turning, the tape head is turning. In this case, they're all turning right. So I'm just going to put R, R, and R. Again, I'm sorry for the terrible handwriting. I'm not the best at writing out stuff with my trackpad. In state Q, you could also see a blank, and then you go back to state Q. So you see, you're in state Q, you could reach state Q again, right? So that would be like a loop, right? And what makes it a loop is that if you encounter blanks, so blanks are, right, you see nothing. Blanks are basically like empty over here because state Q is your starting state and you're seeing blank in state Q. If you see that, that means that you never like inputted any ABC because ABC is what I could input as part of my sigma letter. B is part of my tape alphabet. So that means that if given a lambda, I'm going to see a B in state Q. And if I see a B, what do? I replace the blank with another blank. Any questions? I'm just gonna mute. Okay. If I see a blank, I replace it with another blank, and then I turn right. Right? So in the tape method, I see a blank, I replace it with another blank, so I'm going to whatever I'm replacing on top, I'm going to write it over here. And then I turn right. And I'm still in state Q, right? I never changed my state. So I'm going to be in state Q. And if I see a blank to the right, to my other right, it's going to be another blank, right? So I'm seeing blank again. I replace it with a blank. And remember, this blank goes on infinitely to the right side. So if I keep on turning right and then I replace it with another blank, then the tape is going to continue infinitely, right? So that's what you call a diverging state, is that if you see a blank, replace it with blank and continue to go to the right without changing the B's or the blanks, then your machine never stops. It diverges. It keeps on going on forever. That's diverging. Okay. In state X, I'm done with state Q, right? I took care of all of the instructions. If I see A, B, C, or a blank, that's what happens in state Q. Now I'm in state X. In state X, I could reach state X if I see a A, B, and a C, right? So what that means is that it's a loop, right? So if I'm in state X and I could reach it back, that's a loop. Similar to state Q, right? If I'm in state Q and I could reach state Q via blank, that's a loop. Loop in this case means cleaning star. So A, I'm not going to write that it replaces with the A because it's like kind of given over here, right? And then I'm just going to say that I turn right. Same with state B. I mean, same with letter B. I see a B, I turn right. I see a C, I turn right. And now I see a blank, I go to state Y. You see? In state Y. This is state Y, and I get there via blank. Replace it with the blank. You don't really have to write it. Replace it with the blank, and then we turn left. So when you're turning left on the tape, it means that instead of going right, you're obviously turning left, right? So over here it's like A, and I'm gonna say Q. Let's say this is my state X, right? And then I go to Y, but instead of going like to the right side, I'm going to go back over here and then be in the left side and in state Y. So I'm like looking at over here and there's something in X. This is a little bit confusing. I'm sorry. The drawing was a little bit confusing. Mm, now in state, I took care of A, B, C, and blanks in state X. And in state Y, it's a loop on A. Okay. Loop on A, turn left. And then in Y, if I see a B, I go to state S. That's via a B, and I turn left. If I see a K, then I go to state T in state S. Wait, so
how do you even what's
via a K, and I turn right. This is my automaton for this instruction. Sorry for all the noises. I'm a little bit outside because they're having constructions in my house. Okay. So let's get writing the regex. So Oh, I never mentioned these. This is the machine, right? So we have Q, sigma, tape alphabet, call it. The instructions, Q and then F. Oh, there's some comments. Let's see. And Q is like all my states, right? So I have Q, S, T, X, Y, and then sigma is my alphabet that I could input, and then the tape alphabet blanks A, B, C, A, E, K, and then F, which is the final state. And then this is the instruction. I forgot I think it's data or something. But data is this basically. Um, let's make this smaller. So over here we could from this we could make our regular expressions. So there's three things it wants us to do. Let LA be the set of strings which M accepts. Now M is only going to accept if we go from Q to the final state, right? The final state is T in this case. And then LR is going to be the set of strings which M rejects. So M rejects is basically if it doesn't diverge, but it doesn't accept, and it gets like stuck somewhere in the machine. And LD is going to be the set of strings on which M diverges. So that's going to be, in state Q or like wherever we see a blank and we continuously go on to the right side. Because this is like a one-way infinite tape to the right. So it could only go in the right directions. It cannot go on the left. There are like it's not going to be in 320, but there are like tapes where it's like two-way direction, two-way infinite tape. But anyways, let's do LA first. So LA is going to be the set of strings which from the machine gets to T, right? So to write a regular expression for this, right? Okay. Part A, write 8 distinct strings that belong to LA if 8 such strings does not. Okay. To just do part A, just make a regular expression and any string generated from that regular expression will be anything that will get to T and will be accepted by this Turing machine. So first, we do not want to diverge. We do not want to see a blank in Q, right? So we need to get from Q to X. We could do this via A, B, or C. So okay. Let's make this go a little bit down. So A or B or C will get us from Q to X, right? So we're gonna change state to X. This is our path we want to follow from Q, X, Y, S, and then to T. Let me circle it again. That was a bad circle. I double circle it to indicate that this is our final state. So this is from our state Q. And we see that A turns into uppercase A, B turns into E, and then C turns into K. Now we're in X, and this is my X over here, right? In X, I could see A, B, C, and then loop. So I could see A or B or C. And then what I'm going to do is like star it all to indicate that it's looping. That was a bad star. Okay. Um, this is so bad. Okay. Get the K right here. Okay. This is good enough. Okay, this is my X. And now the way to get from X to Y is that I see a blank, right? So I'm going to all this on the tape, and then eventually when this finishes up, right? B, or whatever it is, it finishes up, I'm going to hit a blank eventually on my tape. And that signifies I switch from X to Y from the left side. And then when I switch from X to Y, I'm going to turn left. So I'm looking at right here. Okay. From Y, I could get to S, right? To see that, I need to see a blank. Oh, I also loop on A. If I loop on A, that means that I get to see any amount of A's right here, right? So I'm going to do A star, and that's when I'm in Y. Okay. And from A I get to S by seeing a B. So whenever I'm seeing these A's, I keep on going left and left and left. So that means that in Y I'm seeing like A. You see my directions is turning left and left and left. And until I finally see B, right? So my B should be coming before my A's. So I see one B and I immediately switch to S. And in S, um, I have to see a uppercase K, right? Uppercase K. How do I see a uppercase K when I'm in S? Well, I see that in state Q, right? In state Q, I remember that I turn all my lowercase letters into uppercase A, B, and C. And the only way that I can see uppercase C ever when I'm in the left side, right, is that I see a C in state Q. Okay? So when I see a C in state Q, that turns into uppercase K, right? And this would like be basically canceled out because I would have to see this is like what do you call cleaning star, and then if it doesn't transfer any of the letters to uppercase, it's only in state Q it does. So I have to see a C in state Q, and then in state X, if I see a B, I turn right, and then I could loop on Y. Sorry. I loop on Y, and then I change to state S, and then I see a B right here, right? This is all going to the left side anyway, right? So I would have to see a B to the left side of A, of my ace. And then over here, and now I turn more to the left, right? Because B is also going left. So over here is when I'm in state S, and then I see the C. On the tape, it would be a K. Remember, in state Q, it turned to a K. And then I go to state T, which is my accepting state. So this would be my LA. Um, any questions on LA? Okay, let's do LR, which is the set of strings. Oh yeah. So I think over here it says to generate eight distinct things that belong to LA. So like anything from over here, right? C, B, A, or like CBA even, or like just CB because this is cleaning star. Anything from there, just write eight times, and then that should be your answer for A. Um, well, B is also the same, right? A regular expression that defines LA. If such regular expression doesn't exist, prove that it doesn't exist. Um, okay. And then C is complete a formal definition of a context-free grammar that generates LA. If such grammar doesn't exist, state that it doesn't exist and prove it. Okay, so context-free grammar, this is more of the older topic, but so you'd have a S, and then you just turn this regular expression into a context-free grammar, which is like the CB stays the same, right? CB. Now this A, you could loop on this A, so you could write another one. I think she doesn't like lowercase letters that look like uppercase letters. So you could do something like D, and then D can go to something like um D or A or lambda. That. Let's do LR. Okay. So for my sigma, right, is ABC. If I see a ABC in Q, I know to go ABC or like a blank in Q, I know to turn to X. And then in X, I have instructions for all of them too. And then in Y, I would get stuck if I saw a C. Because I know for A, I could loop any amount of times over here. For B, I'll switch to S, but for C, I have no instructions for C. There's nothing over here that would signify what I would do at C. Um, it's not asking for a regular expression for where it rejects. So I think like usually there's not much with LR, but they ask for where L accepts and where L diverges. So I'll do diverges instead. But recall. It can reject in state Y when it sees a C, and it could also reject in state S when it comes across uppercase A or E, because remember it only accepts if it sees the uppercase K. So there's no instructions. What if it encounters the other ones? It would reject, right? And where diverges is going to be only in state Q, because in state Q, you have this instructions where you see a blank, you go to the same state, and then you keep it the blank and you turn right. So this is basically your key, key to like diverging, right? So like I said in the beginning, it would only diverge if it saw nothing, if it saw a blank, because state Q is the starting state, and if it saw a blank at the start, that means that I never gave it any input, which is lambda. Any questions so far? Okay. So Daniel, do you think it's a good idea to do another Turing machine problem, or like do you guys want to do pumping lemma?
Up to like up to you guys. What do you guys want to do?
Yeah, up to you guys.
What's the hardest thing that to get down?
The hardest thing to get down, I think it differs from person to person. For me, I personally found pumping lemma a little bit harder on the second midterm, but then it should also not be your main focus because pumping lemma is like a more like a theory base, so it's kind of harder to figure out if you even have to use pumping lemma because if you there are times where you just like could write the regular expression or the automatons or the context-free grammar and you don't have to use pumping lemma at all.
Got it. Okay. Okay.
I would focus on what you like, are best at because this exam is long. There's like a lot of questions and it's not meant to be finished because it is like uh you could score more than 100 on it. I think you need at least like a 60 or something. But if you take a look at this previous exam, it has like 35 questions and you cannot, you know, physically within the time it's like 60 minutes or so.
Wait,
Um,
Rashawn, that's all the versions combined. So that's the one I'm sending
oh,
in the chat now. Um,
okay, sorry. My
she'll take
bad.
like yeah, she'll take like nine of those. So the exam's gonna have like nine questions.
How many of those questions would be pumping lemma? How many of those would be a Turing machine?
I
Like
think
yeah, go ahead, Rashawn.
Sorry, I never took Obrenic. I'm like going off of Riba, but Riba did two of each like topic of the newer topic, like two Turing machines and then I think two pumping lemma or so.
Oh, you took
Um,
Alex Riba for
yeah,
um
yeah, I took Riba.
was he easier than Obrenic?
Easier in terms of grading, yes, but he went a little bit more theory, but like he taught us stuff that Obrenic didn't go over. Like we had to do a lot of conversions. It was more like algorithm based. But Daniel, do you have any idea of like Obrenic's exam?
Yeah, so it's gonna be a lot of exam one stuff still. Like a lot of these problems, they're not actually gonna be pumping lemma. So you're gonna have to know how to tell when to prove it's not context free versus when to actually draw the grammar or automaton, etc. And then there's like two Turing machines usually. So that's guaranteed. But yeah, exam one content and pumping lemma is like gonna be intertwined for sure.
Are we gonna have to draw any graphs? Like any automatons?
Yeah, you
Hmm.
might have to, yeah. I will go over like one example towards the second hour of the session where, yeah, you will have to draw the automaton.
100 like on the exam, that's 100% guaranteed.
It's not guaranteed. Nothing's guaranteed. She might give a lot of pumping lemma. She might go easier. It's up to how she feels when
Is
she's
there
taking the
is
exam.
there a template that she gives?
Is there a template?
Yeah, that she gives, like of
Oh,
saying like, what's on the exam.
no, not what's on the exam. That's like what you learned. Template for pumping lemma. I don't know if she gives it anymore. She gave it when I took her.
I have what's something that was in the group chat in the Discord. Um, because
Yeah.
the pumping lemma proof from Lauren.
Yeah, you can definitely use that to help guide you as well when you're writing the proof.
Is that the same thing that she uses?
She
That
uses she
Obrenic?
uses what you see. So if you can scroll down a little, Roshan,
Yeah, gotcha.
yeah, you see the B where it says answer.
Yeah.
So that's well, I mean, this is the answer key, I think. But if you go on the blank version, she gives you some sentences there.
How come she doesn't have an answer for A?
Because it's
That's
not context free.
hmm
How do you determine that?
Would you guys like to go over pumping lemma right now? I could switch gears or like would you want another example with Turing machines? Okay. I'll take that as switching gears. If at any moment like you'll have any questions, just pause me.
People are saying Turing machines in the chat.
Okay. So I will circle back to problem number 2 after another Turing machine. Wait, I'm not able to see the chat. Okay. Okay, I see. Let me get rid of this. I took a screenshot instead. So let me scroll down. That's context-free grammar, automatons. Was this a question? Yeah, that is a question. Yeah. I'm trying to look for one with like less states. I think they all have like 4 states. Okay. This seems good. Okay. Give me a right now. I'm gonna do this one 32. Okay. So, like before, I'm going to, oh, shoot, I forgot to show the tape method. I guess this is a good time to show the tape method. But automatons for this would also be pretty nice. But this is a short stay, right? You go from Q to X to A. Actually, I think tape would be a little bit better because you go back over here from X to Q. Sorry, I meant automaton would be better. So let's start off. We got state Q. From Q, if you see A, you go to X and keep it at A, turn right.
And I'm not dead.
If you see a B, you loop. Loop and then turn right. If you see a C, you also go to say X. And if you see a blank, you loop.
Wait, I have a question. How do you know you're supposed to loop back to Q if you see a B?
So over here, you see in the instructions, you see a lowercase b, and then you go to state Q back again. So that's a loop. If you're in state Q and you go back to the same state, that's going to be a loop. And then this is what you replace B with. So B doesn't change, but you just like loop back. You translate this as to a cleanly start. So when you're writing out the context-free grammar, when you see B looping to the right side, there's going to be B star.
So any letter looping back to itself is a cleaning start?
Yes. Yep.
Okay. Thank you.
Okay. Okay. We're done with okay, I got A, B, C, and then blank. And then I'm in state X right now. In state X, I see A, I go back to Q. And then I turn right. This automaton can get a little, I mean, this question could get a little bit confusing just because you're going back to a state you previously came back from. And then I do that same with the C. C, I also turn to go to Q from X. And then I loop on B. Right? Turn right. When I see a blank, I switch state to S in X. Blank, turn left side, and then go to S. In S, I go to state W via A, and I turn right side in state W. And I'm pretty sure W is the final state. Let me check. Yep. So F signifies the final state. So when you reach F, it basically means that your automaton will accept your regex, or like your input, your string, right? And then again, this is the tape alphabet. Over here, we don't have any uppercase letters besides blanks. But blanks are basically on all the tapes. You will always have a blank on part of your tape alphabet. And then this is your sigma. This is what you're inputting, right? You would only have lowercase letters in your regular expression. You will never have anything from the type alphabet because you cannot input type alphabet when you're giving an input, right? And then this is my Q. These are the states, Q, S, X, W, right? These are my 4 states, Q, X, S, W. Now let's do LA. Okay, let me see any questions. Okay, no. LA is when I get from Q, X, S, and then I reach W, right? So LA.
I'm sorry, I have a question.
Yeah.
How do you know that LA is when you reach all states, a Q, X, S, and W? How do you know that?
Well, I take a look at the path that I've built, right? This is my automaton. I see that I need to get from Q. This is my starting state, and I have to somehow end up in the final state, which is the accepting state, right? And to get from Q to the accepting state, I have to go through X, S, and then I get to reach W.
Okay. Okay. Okay.
Mhm. Okay, so first of all, I start off at Q, right? So Q, I see A, right? Well, I could loop on a B and B star, but I would have to get to X, right? I get that via A or a C over here. A or C. And I do not want to, in X, I do not want to go back to Q because Q, I could diverge in it and I would have to see A, C again to go to X and then go to S and then W. So in X, I would only do B star over here. Right? B star. And then eventually, after this B star is done, I'm going to hit a blank. Let me write this blank a little bit further. A blank in X. I'm in S. Now I turn left side. Now I'm in state S. In S, I would only have instructions for A, right? A to go to W. Wait, hold up. So if I'm in X, actually I might mess it up a little bit because I'm not sure if I would be expected to go back to Q and then do this again. So maybe I will do that as another part. So start off with the same thing. B star, this is my Q, A or C to go to X. And then in X, I could see A or C, or B. Okay, let me do B star first. And then I could do A or C. A or C to go to Q, and then from Q I could see B star. B star, and then B star, and then A or C. I'm not too sure actually, because then this thing would be like looping. Well, it is a loop actually. So I guess I could cleanly start the whole thing. If I could cleanly start this bit, then I guess I would just have to combine this and the first part of the answer. You see how this is like a loop? You go from Q to X and then you go to from X to Q, but then you could go from Q to X again and then do this any amount of time until you hit like a blank over here. So I am thinking um that it's probably like a loop, right? Let me see. So B star over here, Q, and then you see A or C to go to X, and then from over there you get to C B star, or you could like loop A or B, and then B star, and then A or C, and you get to over here, or you could skip that, and then you would have to end with the A to get to S. So I think this should be the answer because again, if you cleanly start, you basically get rid of this bit. Like, you see what I mean? You get rid of this bit and you'd have the answer that we previously had. So let me check. Okay, this is what she did. Um, B or A or B, B star, A or C star, and then A. Okay. Is the whole thing cleanly starred? Yeah, the whole thing is cleanly starred. Um, you see, if I see a A, okay, I could go to X and then I would hit a blank and then go back left and then okay, I see. This question is a little bit confusing because again of the looping part. Mm, would you guys like to see another question? Because I think this is confusing. Let's do this one. Yeah, there's no going back to the same states. Okay. Yes, sir? Okay, there is. Uh, no, let's do one of the longer ones. Actually, let me get rid of everything first, and then we can
Oh, hello.
yeah,
Yeah,
yeah.
I'm so sorry. I had a question on the previous one. The final part was
Mm-hmm.
capital B, and then you put A to, so that A was to go from S to W?
Wait, this one, the one with the multiple things.
Yes, right here. So,
Yeah.
in your final answer for L of A, you put
Mm-hmm.
A at all the way at the very end after you completed the loop. That was to go from S to W, or was that from?
Yes.
Okay. And then because X to S is just capital B, we just don't place that there?
Yeah, you don't place any capital letters in your final like regular expression.
Mm-hmm.
So blanks is just like stuff you encounter on the tape.
Mm-hmm.
And that's just to signify basically like a bookmark. So like you're finished, like you have, this is going to be finite, right? Your regular
Mm-hmm.
expression is going to be finite. So you're going to hit end of the like end of the string at a point. And that ends is signified by your blank. So when you hit a blank, you're like, okay, I hit the blank. And now I have to check what state I'm in when I hit this blank. If I'm in state X and I hit the blank, I go to state S, but I go from the left side. So that means I turn left when I go to switch over to state S.
Mm. Got it.
Mm-hmm.
Thank you.
Wait, I have a
Um,
question. Oh, sorry. Go ahead.
oh, okay. I have a question as well. So, the part where we went from the second loop, where we went from Q back to X, is it possible after we had A or C for to get back into X that we could have had a loop on B inside of the expression and then we went to the blank state, or that is impossible?
I'm sorry, I didn't catch that. To get a loop on X?
Yeah, so let's say going through the expression, we were in X and then
Mm-hmm.
we took like A, for example, and then we went
Yeah.
back to Q. Then from Q, we took maybe C, and then we went
Mm.
back into X. Is it possible that when I go into X, I can have a loop on B? And then from the loop on B, go to the blank state, which would do the transition to S, or that is impossible?
Yeah, that's possible because in X you are like looping on any amount of B's. And then you could um you to transition you'd have to see a blank, but then you could also pick a or a C and then go to a Q. So that's what she's doing over here is that you could either take like a B and then um oh, this whole thing is like cleaning star, right? You could take a B or like A or C and then B star and then have the loop again to go to Q. And then this whole thing is like starred again.
Okay, so I was wondering, like, could you have a B cleaning star after the second A union C, or that wouldn't be possible?
Mm, well, the thing is that after the A or the C,
Because I'm assuming that A or C is the one that we take from Q to go back to X. That's why I was asking, like, the B cleaning star could have gone after that one, and then the blank state would have been there. Then we looked to the left, and then we filled it in with an A. But I'm not
well,
sure, like, if the B cleaning star would have gone in that position.
honestly, I'm not too sure either. This question is a little bit too confusing for me, but I think so. You could also have like a B cleaning star because like you said, it's like a loop, right? So you are going to end up in state X, and then you could have like a B cleaning star in state X, because that's something you would see.
Okay.
Uh-huh. Uh, let's do another question. This is a little bit too
Wait,
confusing
I do
for
have
me.
a question though. How come A is the last part of is the last thing in
Okay,
the final answer?
so A is also the last thing in the answer I got, which was kind of wrong. Like the whole expression was wrong. But then A was the last thing because you need A to go from S to W, and W is the final state, right? So what do you call? When I hit the blank, I look to the left side, and then the left side, I'm in state S, right? I'm like, okay, to go from S to W, I'm gonna have to see A right after the whole expression over here. Does that make a little bit sense?
Not really, but how come you go left? Why do you go left?
Why did I go left?
Yeah.
Due to the instructions right here. So in X, I go to okay, in X I hit a blank, right? And
Yeah.
then I transition to S.
But you're
You
going
understand?
right.
I'm going left.
Oh, but you're transitioning right to S. Okay. And you're
I'm
hitting the
sorry.
blank and you're hitting the blank when you go from X to S.
Okay, so this is the tape, right? I'm currently, okay, this is all of the input I've had before, and then I'm currently in X, right? When I see a blank, I'm like going all the way to the right, yada, 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 and then I hit a blank, right? After my input, my string is done. I hit a blank. I'm like, okay, I'm in X right now. Now what I do is that I want to turn left, left over here. Now I'm in state S. So I'm looking at right here, right before the blank. And right before the blank, I'll need a A to go to state W. Now I go to state W and then I go right and then I'm at W. So I'm looking at over here in W. And W, it doesn't matter what you see because that's the final state. So your regular expression or like your input would be accepted regardless.
Interesting. Okay.
Mhm. I don't think maybe she will like put this like difficult stuff on it because honestly, like it does get like super confusing due to the loops and stuff.
Oh, I have another question. Not pertaining to the question itself, but let's say you wrote like, for example, we did the regex, but like we did half of it correct. Does she give like partial credit for that, or she just gives it the whole entire thing wrong?
I believe she gives partial credit, but again, I never took her. So, Daniel, would you have any input on that?
Yeah, there's partial credit for everything.
Okay, okay.
Yeah, yeah.
Oh, that's great. Yeah. This one has more states than the previous one, but I think it's going to be a lot more simpler because there's no jumping back to the previous state. It's kind of more direct where you just keep on changing states and states. But it is a little bit more confusing at the part, I guess, with the uppercase letters. Uh, but shouldn't be that much, to be honest. Let me make it a little bit more smaller. Okay. Um, this one, I think also the automaton would be a better choice to use than the tape machine. So let's do the automaton. Honestly, the automaton is more better with like, that much states. If you have less states, like three, and it doesn't switch back to like its previous state, then do the tape machine. Um, I am starting at state Q, and then A, B, and C gets me to X. Looping on B. And right. Uh, in state X, see A, B, C. Turn them into A, E, and then a K. And they're all turning right. Oh, okay. So I am now in X, and I could loop on all A, B, and C's. A, B, C, and they're all turning right. And if I encounter a blank, I switch state to Y. In state Y, I um I okay, I could encounter the uppercase. Okay. never mind. This also goes back to Q. So it would also have that loop. But let's try to see how it would work because maybe it will be less complicated than before. So I see a B and I go to W. And then in W, okay, let me just get this out of the way. A E K. All turning right. In W, looping on A, B, and C. Let me see if I can just copy. Okay. Can I copy them? Oh, okay. Let me just write it out. A, B, C, turn right.
This is right. This is right. Right.
Right.
Right. No.
And then from W you can get to T via K.
Wait, let me show you. Wait, right.
The K and then you turn right to state T. Okay, find LA to be the set of strings which M accepts, which is going to be when we reach T, right? That's the final state. Okay. Let me see part A. Write eight the strings that belong to LA. That's going to be, just find the regular expression and then generate eight different stuff from it. Let me get this more smaller. I broke up two, but that's fine.
Isn't it for the loop for W, it goes left and not right?
For W? Oh, oh yeah, you're right. Sorry. Okay. L, L, L. Anything else? K, okay, that's right. Right, left, blank, okay, left, okay. So let's do LA. We wanna get from Q, X, Y, W to T, right? So in Q, I wanna go to X.
Can I get up?
I could encounter, I don't want to diverge in Q, so I would want to encounter A, B, and C. A or B or C in Q. And then I turn them into A, E, and then K. And then I transition to X and X. I could loop on, okay, they all are turning right, so I'm entering X from the right side. And then loop on A, B, and C. So my Q. A or B or C star. And then from X, I go to Y when I hit a blank. So after I'm done generating the string, I'm going to hit like a blank right here. In state X, I'm still going to be in state X when I see this blank, right? And then I turn left to go to state Y. Now I'm looking to the leftmost side right next to B. Um in state Y. In state Y, I see uh uppercase A, B, and C's right here. Then I could loop right? I could loop back to Q, and it's like a whole loop. So that's that. Or how do I change my state by seeing a blank? Not a blank, sorry, a B to W. And then to go from W, uh, W, I'm looking at over here where I'm like looping all the stuff. And then C, K. So I'm assuming you would have to see A, C, and state Q. Ah, C, A, or B, or C star, and then B. Uh,
This is a 5%.
mm, okay. Let's see. Okay, yeah. So this is for LA. This is what she put. Um, basically what I had, but she put this inside another symbol. I think this is theta, or omega. I'm not too familiar with my Greek letters, but
That's
this
little
is
omega.
this, yeah, little omega. So she put this whole thing inside that, and then that's like when you expand it out, it's going to be the same thing as this. So that's for where accepts. Any questions?
Okay, why'd you replace the whole Q state with C?
I'm sorry?
So for Q, it says A or B or C, and then you said you went left, and then now it's C with A or B or C clean star.
Okay, I'm in Q, and then I never turn left in Q. Oh, are you talking about the K right here?
Now I'm saying like, so we went from A, like that state A or B or C, A or B or C clean star, and then B to the blank. And then you
Mm-hmm.
said the answer was C, A or B, C clean star B. I'm like, where does the C come from? Isn't it supposed to be like before B?
Oh, okay. So I'm in state Q, right? And I could encounter A or B or C to go to X, right? So this is just like roughly writing out what I could encounter. They all take me to X, right? But when I go back, I make it more specific, right? So I see that when I go to X, I could loop on A or B or C, right? Um, and then when I go to Y, I'm like, okay, let me go back. Let me go back and then rewrite all the stuff that I've seen before to make it more specific and to go to T, right? So in Y, I hit a lowercase b and then I start going back. So I need the B right here, right? Right before at the very end to go back. Now I'm looking at the left side and then I see in W, I'm like, okay, W is basically this bit. W is right here. I'm looking at to the left side of B, right? W. So I see B, I see A, B, C. I keep on going left. See, in W, you're going left. I see all this stuff. And then over here, I'm like, okay, to go from W to T, I need to see a K over here. And K, I'm like, oh, in Q, I turn all of these letters into uppercase A into uppercase A, B into uppercase E, and C into uppercase K. So I'm like, in W, okay, I need to see a uppercase K right here, right? So what was that before? It was a C. My C in state Q would be turned into uppercase K, and that's why I have a C right here, because in the um in the instructions, it turned them into uppercase letters. So when I see the K, I turn right and then go to T. Does that answer your question a little bit?
Yeah, so like let's just say in the loop for W, right? Instead of going left, it goes right. Then that's what will be C before B, or still?
The loop in W?
Yeah, let's just say instead of going left, it goes right.
Oh, it goes right. So it wouldn't be looking at this. It would be looking at B, this lowercase b, and the stuff that comes after B.
Oh, okay.
So what I'm saying is that instead of looking out over here, right? Since um it would be like over here. Like it would be after B, so this bit would come like right over here for W.
Oh, okay. So like
Um
it has an N and a C.
yeah.
Okay. Thank you.
So like you said, right? Instead of like what if the loop was going right instead? So it would be like right like that. Oh shoot. Sorry. Let me copy this. It would be like this if W was turning right instead of left.
Okay.
That means you're writing more input onto the tape. The tape is to the right side, right? So when you're going left, you're basically like rewriting all the stuff that you have seen before. This is a rough scratch. So I made it more specific by making Q choose a C, because if you choose a or a B and you encounter this in W, you cannot reach T, right? Your machine would be stuck because there's no instructions for uppercase A or E. So that would be L rejects. Like that's something that you will reject. But this is L accepts.
Okay. Thank you.
Mhm. Let's copy this and put it right here. Um, uh, let's see the next part. Write 8 distinct strings that belong to LR. If such strings does not exist, state that they do not exist and prove it. So whenever they say like prove it, you have to like keep in mind that it could be that you might have to use pumping lemma for it. This sessions goes until 2 p.m. So um would you guys like me to switch gears and move on to pumping lemma, because there will be a slight review on the older like topics such as context-free grammar and stuff. Or do you want me to complete this question? Um, go to pumping lemma? Okay. So um let's do pumping lemma. So for pumping lemma, there's two times you have to use it. There's pumping lemma for regular languages, right? Mhm. And there's also pumping lemma for context-free grammars. So the way you figure out whether the question will ask you, right? So write a context-free grammar for this language, right? And if it doesn't exist, prove why it doesn't exist. So you know you have to use the pumping lemma for context-free grammar. And if it's like a regular language that you have to use pumping lemma for, then the question will state, write an automaton or like a regex for this language. If it doesn't exist, such automaton or context-free such automaton or regex doesn't exist, then prove that it doesn't exist, right? And a pumping lemma is it's like a proof by contradiction. So basically, you would assume the opposite, that okay, this language is regular or this language is context free. So let's focus on regular languages, and then we can do a context free pumping lemma. But let's see. If this book does have, okay, it does. So let's do problem number 19. Okay. Problem number 19 is, let L be the language over the alphabet A, B, C, G that consists of exactly those palindromes, right? Palindromes is like same thing front and back. So if you flip it, it's the same thing. Whose length is divisible by 4, but the last symbol is B. Whose length is divisible by 4, but the last symbol is B. If L is regular, then use part A of the answer to draw a state transition graph, right? They're not asking for regex, they're asking for a automaton of a finite automaton that accepts L and do not write anything in part B. If L is not regular, then do not write anything in part A of the space, but complete the missing part. So they gave you part A or B, and if it's pumping lemma, then you do part B. And if it's not, if it is regular, then you would draw the automatons, right? The circles and all that in part A. So that's another thing. So we going to, okay, to figure out if it's, regular or not, there's some properties of regular languages or like regexes and stuff. So regular languages, memory is very limited. You cannot keep count of the numbers of A's you saw, right? If it's like A star and B star, right? And I want to match up their numbers. I want the same number of A's and B's. The cleaning star does not keep memory of how many times it saw the A's and how many times it saw the B's. It just is 0 or more A's and 0 or more B's, right? So it cannot keep count like that unless you specify it. You specify it's exactly 3 A's and exactly 3 B's. So exactly 3 A's and exactly 3 B's. You can do this as a regex, right? A, 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 and B, B, B. You could also have something in the middle, like, any number of C's in the middle. That would be like a C star. That's a completely fine regular expression. But what is not is that when it asks you the same number of A's and B's without specifying any specific number. So that's one thing. So if A to the n, right? And B to the n, that is not regular, where n is any arbitrary number. If there's any links between them and it doesn't specify that amount of number, that is not regular. Which in this case is like saying, right, that consists of exactly those palindromes. Palindromes is like if I see 2 A's over here and it has to end with 2 B's, right? You cannot do this with regular expressions, because again, oh, the last symbol is B. So the first symbol has to be B and the last symbol has to be B, right? Whose length is divisible by 4. So let's just do the easiest one. B, A, BAAB, that's a palindrome back and forth, right? Okay. So we could use this, right, as our string. So what we do is that when we write out our pumping lemma, your template is going to be given. Let me try and find a clean template. It should be actually Daniel, do you have this problem without the answer key?
Yeah, I think I sent it to you, or I also sent it in the chat.
Oh, okay.
Yeah.
Um, save. Or did it get saved? Okay. Question number 19. The template, I am not sure. I heard from some people that she doesn't give it anymore, but do not panic. It's going to be the exact same format as like this. If you write it out, I'm pretty sure she is going to accept it. I know it's kind of wordy, but it's better than Loki. It's better than Loki Bachlan because I don't think he has like any type of template or anything. But anyways, this is going to be our pumping lemma template, right? So we first assume the opposite, that's step one. Let's assume that L is regular. So if it is regular, then there's some properties. Okay, let me put this up a little bit more. There's going to be some properties uh palindrome. Oh, so and then you're going to state the property that it breaks, which is the palindrome. You could do a length of 4, right? For with like regular expression or automaton. If you could write out a regex, then it's automatically regular, and you could automatically make an automaton for it. Oh yeah, let me do the category thingy. So like anything that's regular is automatically context free, but not anything that's context free is not regular, you know? Regular languages, and then context-free languages. And then on top of that, I think is Turing decidable or Turing recognizable. Turing recognizable. But there's like a subset to this, you know? For pumping lemma, just focus on regular languages and context-free languages. So let's do this. So our property that is broken by this statement is a palindrome, right? Because we cannot keep track of how many letters we saw back and forth. And so we assume the opposite, that L is regular. If L is regular, then there's going to be a pumping constant for L, right? The pumping constant is basically you set it. It's any constant. It could be any arbitrary amount of numbers. It could be like 1, 2, 3, 4, up to like it's infinite, basically. Assume the okay, let B the pumping constant as in the pumping lemma for L. So our pumping constant sorry, that's bad. Is okay. And let W0 be inside L, be the language. It's basically a string inside our regular language, right? So we could just use this, which is BAAB, because it starts and ends with B, right? the last symbol is B, and the length is divisible by 4, and it's a palindrome. So we could say that W0 is going to be B, A, B. W0 belongs to L because it is divisible by 4 and it ends with a B, and it's a palindrome. You just state this property. And you write it over here. W2 must pump because the length of W0 is going to be less than our pumping constant. It's a wait. Yeah, it's less than or equal to, or is it strictly less? I think it's less than or equal to. Check. Okay. Oh, it's greater than. My bad. I'm sorry, I haven't done pumping lemma in like a since last semester. Okay.
No, there's something on my hair. There's bug.
Okay.
There's ladybug on my hair. There's ladybugs on my hands.
Greater than what do you call? Okay. Um,
Ellen, please.
I'm wondering if I should like use oh, actually I do have to use it because I'm trying to prove that the arbitrary number cannot be uh cannot be keeping track of. Right? So the B's could stay the same, right? Like the example that she gave is that our B's stayed the same and then oh, okay. But I assume that we could also keep the A's to be arbitrary. Let me just use the string that she used because I think that's a good string to be used over here. For N, and then I'll use two A's and then for N over here too. And then you just state the property over here, W0 must pump because the length of W0 is a long string. So what that means is that it's going to be greater than our pumping constant. So what do you call? You're going to set N going to be greater than K. N is greater than K. And when I combine these, it's like 8N
Rate me on water. Oh.
plus 2 because of these two A's is going to be greater than K, or greater than N, which is greater than K. But you get to decide the the string that belongs to L. And make sure to like pick like arbitrary numbers. So that way when you pump it, it's going to show that it's not regular. In any pumping decomposition of W0, the pumping window satisfies the following property. Um, what do we have to state again? I think is that you can decompose that. Oh, the length of the pumping window. So length of the pump. Okay, so when you decompose a regular one, you would have X, Y, and Z. And the pumping window is going to be X and Y. And that's going to be at most your pumping constant. less than or equal to K. So see your pumping constant, it could be the amount of time you pump up or down. So the pumping window has to be less than or equal to, you constrict this so you do not pump this B as much as this B because it's going to be too small since N is already bigger than K. So if N is bigger than K and your pumping window is less than or equal to K, you cannot reach this B with this pumping window. And your pumping part is going to be greater than 1 because you do not want to pump when it's not greater than 1, it's basically saying that you're not pumping at all. So after pumping one time, we obtain a string W1 in which we pumped this Y part up once, right? P plus 1 or just 1. And then Z, which violate the state property because we have more B's than this B over here, and it's not a palindrome anymore. We have more B's on the left side. Left side. Then on the right. Thus, it does not make it a palindrome anymore because there is uneven number of B's, right? And that's what it says. Thus does not belong to L since L violates the pumping lemma. And pumping lemma basically states that no matter how many times you pump up or down, you're still going to stay inside the language. And this does not, it's outside of the language, right? It's not a palindrome, even if it's divisible by 4. And the length, I mean, even if it's divisible by 4 and the last symbol is B, it still violates that it's a palindrome. Right. So we do have like about roughly 20 minutes left. I think it's best to switch gears to Daniel. There are some links in the Discord. If you aren't in the Discord, I think this it's pretty helpful resources and stuff. And also past exams you could look into. So let me see Obrenics Discord. This one I will put the link in the chat. And then there's like videos over here and there's Lawrence's study guide. And also all exams that you could practice from. Please take a look at that to prepare a little bit better for the exam. And put in the chat. W0, you pick your W0 because that it's like you want to pick a string that you know will break it. So W, like Obrenic picked B to the 4n A and then B to the 4n because she knows that by making n smaller than K, you'd never have the pumping window would never be big enough to pump both side of the B's. Yeah, you're right. The string in L has to be long enough and bigger than the pumping constant. I did mess up on that. It has to be bigger than the pumping constant, and the pumping window has to be less than or equal to the pumping constant, and the pumping part has to be greater than 1. So you don't pump like empty string. Okay. Um Daniel, would you like to switch gears?
All right, yeah. So for the last thing we're gonna do is one problem that typically comes up on the exam 2. I'm gonna share my screen. And it is a little bit of a review from exam 1. So let me just share the screen. Okay. Um, okay. I think you guys know that's this problem here, where she gives you a automaton or expression or grammar, and she asks you to interconvert between the three. So we'll go over this one, and this can be found on the same exams I shared in the chat. Okay, so here it gives us an automaton, and it's asking us to write a regular expression that defines L given by that automaton. And the first thing I'm gonna do is I'm just gonna trace this thing and see, how can we write a regular expression from it. Now, the start state is right here. That's where we're essentially starting, and then we're moving forward from there. Our goal is to reach the final state. And so I'm over here, right? And then there is a B to get to the next state, and then some sort of optional loop here, and then A to get to this state. And that's really the goal because we want to move forward. All right, so I'm going to write B, and then this thing where it goes backwards to its own state, that's just a Kleene star when we're translating it to a regular expression. And so the Kleene star starts off with an A, that's this over here, and then an embedded Kleene star, which is just C. So C can repeat however many times, and then a G to go back. So G over here, and then this can take itself, as many times as you wish. All right, and so that's why this would be in star. And finally, when we want to exit that, we can just take an A to move on. So that's A over there. Now, something to mention is that there are two lambda transitions, one forward, one backwards. And so that also signifies that this whole thing here, between this state and this state, is also looping. So that's also in a Kleene star, this one. Okay, so 3 Kleene stars involved in this part of the automaton. And then we are over here, and to move forward, we want to take a B, and then we're over here. And then what happens over here? We have a split. We have two pathways. One is this one, the other is this one. So two ways to get to the final state. And so to signify that, I will, we're going to have to union something. That's what that means. Whenever there's a split, that means union. Now, this will be the first path, which is the top. This will be the second, which is the bottom. I'll do the top first. Now, the top says A or C to get to this state. So the comma means or. And you can also write the comma like this. A over here, C over there. So this is fine. This is also fine. But it's not the same as this one, A, C. This one means A followed by C. Well, this one is just A or C, these two. So this is not the same. Okay? So that's just saying A or C. Let's write that over here. Now I'll make some more space. And then following that is B or G. So B union G. And then following that is A union G. So again, I'll make some more space. A union G. That's the first path, and that should take us to the final state. Now the second path is we start off with a G. Let's let me denote it with green. I can just change. Starts off with G. So that's just the G. I won't put in parentheses. And then we go to C. So C. And then we can take a B, or we can Kleene star A as many times. So Kleene star means 0 or more times. So A star and then B. Okay, so A star and then B. And we saw the Kleene star here as well with the C. That's a single Kleene star. Same thing there. And then that's it. We can close it off here. And that's how you solve this one. Anyone have any questions on this? I think it's pretty straightforward, but it is a review from exam one.
Daniel, you say this is typical to be found on exam two.
I'm sorry, exam two, yeah.
How likely is it to be on our exam on Wednesday?
Pretty likely that these topics will still come up on exam two.
What do you mean these topics? Like the question, just the one question you're going over right now?
Yeah, so regular expression,
Hmm.
finite state automaton, and context-free grammar.
So rejects.
Yeah, and you got to know how to convert between them. I'm sure that's one of the topics she taught.
Yeah,
Uh,
yeah,
yeah, on the other exam.
yeah.
Roshan, if you're still there, I think someone is in the waiting room, or maybe not. If someone is, could you please let them in? I don't know. I don't have access. Thank you. Anyway, so that's the first part. And yeah, like I said, it's likely you'll see some of this stuff in exam two. Highly likely. Okay, and then they're asking for part B is to complete a formal definition of a context-free grammar. I'll use based off what I wrote here. You could still use this, but I think it's more difficult to go from this directly to context-free grammar. And so I'll go from the regular expression. All right, so how do we start the grammar? It's always going to look like this. G equals to V sigma P and S. So V is your variables. That's your capital letters. Sigma is your alphabet. P is the production set, which means just the set of transitions. And S is your start variable, or the string you're starting with. So that's what that means, but you're always going to have to write this. You're always going to have to write G equals V sigma PS. And I believe she does take a point if you don't. Now, V is, the set of variables. So far, we only have S. And then we'll fill it in from there, but for now, we'll leave it open. P is the production set, or let's write sigma first, sorry. So sigma, the alphabet, she usually gives it. But if she doesn't, which she doesn't here, then you have to figure out, well, which letters are we using? We're using A, B, C, G, and that's about it. That's all I see. I see 4 letters. So I'll write that as the sigma. A, B, C, G. And then you can start writing the production set. And it starts with S, transition. And so you have to label the regular expression, and then it'll help you write your grammar. So let's label it. Let's label it. And the way I like to label is I will give a letter to anything that has parentheses, anything that has a star, and anything that has parentheses and star. So these get a variable of their own. So with that being said, let's do that. I see a parentheses star over here. That's this, right? And I will give that variable an A. I'll call it A. And then what else do I see another parentheses star over here. This one. I'll call this one B. This one I'll call C in black. Or you can't use C, let's use D. So this is a star, so also given a variable. moving forward, the b is nothing special. We don't have to give it a variable. But I do see over here parentheses. 1, 2. So I'll call this one E. Okay. And then this one I'll call F. This one I'll call H. You can't use G because G is our grammar. This one I'll call J. This one here K. Okay. So that's it. That's all I'll give variable names to because I'm just using my key over here. All right. And then from there, it's pretty straightforward what you have to do. S is everything. S is everything. So then you ask yourself, well, what is everything? S is always or usually a concatenation of variables, or it's going to be a union of variables. That's if you see a union, like for instance here. Okay. Now here we're concatenating A followed by this B followed by this portion, which we labeled E. Okay, so A, B, and E, like this. Does that make sense? Hopefully it does. It's just a concatenation. And then we have to start defining everything. So all the variables, what are they? All right, so A is, well, A has a Kleene star. Whenever something has a Kleene star, we always say is AA, so the variable itself repeated twice, or lambda, because Kleene star could also be anything, or could also be nothing, I mean. So AA or lambda, and then or anything that's inside of A. So what is inside of A? It's a concatenation of B followed by capital B followed by A. Okay, so B, capital B, A. And then what is B? Capital B. Well, let's see. B is this, whatever we had inside, and that is A, D, which we labeled, and then G. So B is A, D, G. And D is the C star. So we say D, D, or C, or lambda. Okay, whenever we have a star, we do the same variable twice, or lambda, and then whatever is inside the star. All right? And then, okay, we're done with this. Now we have to define,
Doesn't the
yeah.
B have a cleaning star in it?
Does B have a Kleene star? Oh, it does. I didn't see that. Yeah, right here, there's also a Kleene star. Thank you, Vikash. So this is also BB or lambda, because B does also have a Kleene star on it. And then we move on. We were starting to define E now. And E, what is E? Well, inside of E, there's a union. So there's supposed to be some sort of bar. It's split into some two pieces, right? The first piece is this one, and the second piece is this one. Okay, we'll do the first piece first. The first piece is a concatenation of F, H, and J. So F, H, J. And the second piece is, G, C, nothing special. And then we have this K that we labeled. So K is next. And then a lowercase b. And now we have to keep defining. What is F? F is A or C, right here. Let's say A bar C. The union is bar, translates to bar in the context-free grammar. And then what is H? H is B union G, so B bar G. And then J is A bar G. J is A bar G. And lastly, we have K to define. And K, oh, sorry. Oops. So K was our A in a Kleene star. So K is whenever there's a Kleene star, KK, or lambda, or A. Okay? And that's pretty much it for this problem. I wish I could zoom out. I can't. But that's the answer for this one. And then at the very end, don't forget to populate your variables list with whatever uppercase numbers. And your list is right here. Right here. So just copy that down literally. A, B, D, E, F, H, J, and K. And then close. All right. And that's that for this problem. Does anyone have any questions?
Yeah, I have a quick question. For D,
Yeah.
how come you wrote double D? Like,
Double D for D.
yeah,
Let's
is it
see.
because of the clingy star?
Yeah, so D is C in a Kleene star. So if any one of them has a Kleene star, we have to write the variable twice and then lambda or whatever's inside.
Uh, you said lambda or whatever's inside.
Yeah, or meaning the bar. So DD
Oh, okay.
repeating or
Hmm.
lambda or whatever is inside.
How come you didn't write? Oh, you did write lambda. Never mind.
Yeah.
Will will it ever be where you write it repeating? Like there's a clingy star, but you don't write lambda? Is that ever a case, or is that just wrong?
No, it's wrong because Kleene star means zero or more times.
Which is
Zero or
lambda.
more times. Exactly. So the lambda takes care of the zero part. And then or more times is the where we did the repeating, where D can be doubled effectively. So D can become DD, and then let's say this one can also become DD, and this one can also be DD. So then we could keep getting a chain
Okay.
of Ds.
What about like instead of writing DD, you write the can you scroll up for a second?
Yeah, of course.
Back to the rejects. Yeah. So instead of writing DD, can you just write the variable that you changed to D with D, like CD, for example? Could you do
Yeah,
that?
so you can do either this or there's another way. You could do CD or lambda. Whichever one you prefer. You do
Okay.
all your base cases followed by the variable. So let's say inside the Kleene star you have A union B union C star, and let's say you labeled this A. So
Yeah.
then A, you can either do this way, which is what I showed, or A, B, C, like that. Or
Mm-hmm.
you can do A is A or B
AB.
or
Oh,
C
okay.
or lambda. So these are both they're the equivalent. All right, whichever one you prefer, you go with.
Okay. All right.
Any other question? Yeah, no problem. Any other questions?
I do have a question. Would you be able to show you going from a regex to the definite state automata? Would you be able to do that?
Uh, yeah, we do have that as well.
Like, could you go over a problem like that? Like just one problem of you drawing the definite state automata given the regex?
Yeah, we could do it. I don't think this exam has it.
But just like because you said that she can ask
She
um
can, yeah.
that she can ask it like instead of going from a graph to regex, you go from a regex to the graph.
True, true. Um, do you have a question that she asked like that you could find? I have this one open right now on my iPad.
I
I didn't really
don't
prepare that one
I
question.
don't. That was just like an edge case that I was thinking of. Um,
I mean,
no,
I
oh
think it
yeah,
might have been
here.
on your first exam, right?
It was on our first exam. Yeah. Maybe like this, for example. Uh, 1 second. Mm,
I have a question. Will she ever
let's see
ask pumping
that.
limit?
Sorry, what was that, Andrew?
Will she ask, I mean, telescoping, like in like for exam
Yeah,
two?
yeah.
Yeah. Or
She asked on this test two of them. Mhm.
Wait, there's
One of them
telescoping?
was one of this one. this one I think was pumping lemma, and then the second one it was good. This telescoping is good because you know connect the variables. You see there's no overlaps in segments of alphabet letters. So we don't disprove it. We have to write the grammar for it.
Wait, I have a question. If there's an overlap, then what? What happens?
And you see that with this problem, the first one. Yeah, this one here. So here the K, I believe. No, not the K. Let me go back. The P's, yeah, the P. You see, the segments are, you know, truncated by letters from a different variable, you could say.
Truncated?
And so, well, I mean, they overlap. You see this over here? Not a lot.
Like, like where one link is nested within another?
Not, I wouldn't say nested. It's just there's a crossing, if you can see the crossing.
There would be an intersection between the links, and
Yeah, an intersection. Thank
that
you,
would cause it
Vikash.
to not be context free.
Yeah, and then in that case, you're not doing this anymore. You have to prove it. You have to prove that you can't draw a context or a finite state automaton for it.
Like, could you explain how it overlaps? I'm still not
I think,
sure.
okay, yeah, I could show you again, but pen is not working. One sec. So look, you see the variables, you have to do this,
Yeah.
and then you do connect the P's,
Mm-hmm.
and then you connect the I's, right, again.
Yeah.
But you see that, the I region, it spans the P region as well. Do you see that? You can't have that.
Oh,
And then that's where we
I
write
see.
the proof to disprove that this is a context free, or sorry, that this is a regular language.
Okay. Because on what's it
Context
called?
free.
On the
Yeah.
first exam, like on the practice problems for the telescoping, she never had three of the same exponents. She only had two at most.
Yeah, that's here. And
Yeah,
here you would draw the
the regular.
Yeah, you would draw the context-free
Right.
grammar.
And that's what I meant by nesting. How if you go back down, how what's it called? Yeah,
Yeah, this is fine.
how like 4K and 3K are within the eyes and
Yeah,
how
that's
within the
perfectly
eye.
fine.
Okay,
That's
okay,
allowed, yes.
okay,
But
okay,
as soon as you have something like this, for instance, no. Okay? Then you
okay,
gotta disprove it. Okay?
okay. Yeah. Thank you.
And Roshan went over that earlier on, all right?
Mhm.
And also, yeah, there's like Krishan said, there's a video by Lauren and other people in the past, and they went over pumping lemma as well. If you do want to look at other videos, you're always welcome to do that. Maybe that will help you as well.
Okay.
As far as the regular expression to, you know, context-free grammar or automaton, they did also go over that in other reviews. I think maybe even exam one review. You can look at that. There's a videos on the website and on the Discord as well. So you could take a look at those. We're just a little out of time right now, so unfortunately, we won't be able to go over that. Any other questions before we end it? If not, then thank you all for coming and
I have
good
a
luck
question.
on your exam. Yeah, what's
Sorry.
up?
If we have any further questions, could we ask like how could we ask you guys?
Um, we are the Learning Commons tutors. You can schedule an appointment with us. I will give you the link in the chat right now.
Are you guys available on weekends? Like for example, you? Yeah.
No, we don't do tutoring over the weekends.
Okay.
That
Okay.
is the website link. MD's great. That's the website link. You can schedule an appointment from there. You're gonna have to log in. And then, we're available Monday, Tuesday. I'm not sure. Your exam is on Wednesday or Monday?
Wednesday.
Wednesday. Yeah, so you can book Monday, Tuesday if there's still availability, and then someone's going to be able to go through with any questions you have one-on-one, all right?
Okay, cool.
Oh yeah, MD doesn't do 320. All right, guys, good luck on your exams. Bye.
Thank you for hosting the review. Have a good day.
Have
No
a good
problem.
day.
Bye.
Bye.
Oh, by the way, are we going to get the recording for the session?
Yeah, so that's going to be posted on the website, on the QC website. Let me see if I can take you. Oh, wait, I can't. I'm not on the computer. But yeah, on the QC website, under Academics, Learning Commons, and then
Mm-hmm.
there's like resources, and you click on computer science, and there should be like recordings posted and other past recordings as well. So if you want to take a look at those, you can go ahead from there, okay?
Great. Okay. Thank you. Thank you, Nick.
Yeah, no problem. All right, have a good one. Good luck.
You guys
Is there
will.
a feedback form?
There is.
Yeah, the feedback form. I
Yeah,
messaged
I
Michelle.
sent it. Let me send it again. I mean, everyone already left.
Oh.
Whoever's still here, if you could fill it
Well,
out.
we got a
Thank
couple
you.
of us, so we'll fill it out.
The
Yeah, thank
OGs,
you.
yeah, the OGs.
I had to leave in the middle and come back, so I didn't see the feedback form. Thank you.
Oh yeah, no problem.
And thank you guys. This has been really helpful.
No
Yeah,
problem.
actually
All right.
learned a lot. Surprisingly.
Mm-hmm. All right. See you guys. Good luck.
Thank you.
See ya.
Mhm. Oh, Daniel, should I stop the recording? Wait, do I have? Yeah, I'm going to stop.